Same thing. Okay.
And if you can come please little bit closer to mic, I'll put you in mute.
Yeah, okay, Anuj. Put me on mute. All right, let us get started here. The first thing that we have done is we have discussed about the define phase. In define phase, the first step that we have looked into was generate project ideas. After generating project ideas, we wanted to select the right project. After selecting the right project, we wanted to finalize project charter and also high level map. We wanted to do these three things in the define phase. Even before that, we have discussed few more things about define phase. Right? We have discussed that there will be a lot of stakeholder expectations, sponsor expectations, team leader also expects a lot of things, right? And then you take all of those things as input for your define phase and you come up with your critical customer requirements, project charter, stakeholder analysis, communication plan, so on and so forth. Most of the time as Six Sigma Black Belt professional, you'll be dealing with changes. You'll be dealing with organizational culture. You'll be dealing on getting management support. You'll be dealing with various other things. Right? And we have discussed about quite a few change management tools. What are a few of those? Let us discuss. As part of change management tools, we have discussed about SWOT analysis, strengths, weaknesses, opportunities, threats. Then we have looked into stakeholder analysis on how to classify a person, whether he is positive stakeholder or negative stakeholder or a neutral stakeholder. And then we have looked into influence, strategy, right, and reward strategy, various other things. And as part of this change management, we have also discussed about John Carter 8-step, sorry, not 87, it's 8-step change management. Yeah, how to create the urgency, how to build a guiding team, how to get the vision right, how to communicate for the buy-in, empowering action, create short-term wins, don't let up, make change stick, various other things we have already discussed. Then we have also discussed about the types of resistances which are very important. Because as black belt, you are expected to work on change management and ensuring that there is not great resistance from the folks. So that this will be your prime focus. Okay. Parochial self-interest, that means everyone would be concerned about their own self. Selfishness, maybe. And then misunderstandings happen. How will you as black belt professional ensure that misunderstandings do not happen? One way of ensuring that misunderstandings do not happen is using communication problems, right? Addressing the communications properly. Then people have low tolerance to change. We need to start dealing with that also. And then we have different assessment of different situations which we have seen. We have also discussed about, let me delete this, on how to get rid of resistance. We have discussed about various things. And then we have discussed about stakeholder analysis, which was the key, which is mentioned here. How to classify a person as a positive stakeholder or negative or neutral stakeholder. We have discussed about power, interest grid. We have discussed about power, influence grid. We have also discussed about influence impact grid and then the salience model. In salience model, once again, we had three things. We discussed about power, urgency, Legitimacy. Legitimacy means appropriateness of involvement. How appropriate is a stakeholder's involvement? All right. These are few high-level basic things that we have discussed. Then we have gone to actually generate the project ideas. How did we generate? We have looked into voice of business, voice of customer. We have also looked into voice of employee, and also we have looked into voice of process. 4 voices. And we have also looked into the database, which is cost of poor quality. And then we have discussed about few language processing tools which are used to process the potential ideas which are generated from these sources. What are those language processing tools? Language processing tools. We have discussed about affinity diagram, interrelationship diagram, and also we have discussed about goal means diagram, or this is also called as tree diagram. After this, we have also discussed about balanced scorecard. Balanced scorecard. Yeah, we have discussed that always we need to consider 4 things. One is financial metrics. Second is customer metrics. Then internal business process metrics, and then learning and growth metrics. Yeah, balanced scorecard is actually dealing with all the aspects of a company. We want to make profits, fine. We want to increase the customer satisfaction, fine. We also want to improve our internal processes. And also we want to invest on our employees on their learning and growth. And we also have discussed about the replication things, right? If you already have a project that you have implemented, do not reinvent the wheel. Instead, try and replicate the things. Then we have discussed about benchmarking. Benchmarking is considered to be a very good idea of generating many ideas, right? It is another source of ideas. So you can look into collaborative benchmarking and strategic benchmarking. Because in Black Belt we have discussed about internal benchmarking, external, and all that. Then we have discussed about screening for DMA-IC, how to select a project. Then once we have project, how to select a project. We have used prioritization matrix, kind of Pew matrix, in order to select one project. Then we have also looked into how to identify what is critical to customer satisfaction, right? VOC, voice of customer, describes the expectations and desires of the customers. So we have discussed about all those things on what he actually requires. And then from there we need to identify from voice of customer, we need to identify critical customer requirement, CCR, sorry. From voice of customer, we need to identify what is our CCR. And we identified information, we have developed various ways of collecting voice of business. Then we have translated this voice of business into CCR. That is critical customer requirement. What is this critical customer requirement? The requirement which customer actually cares for. These are the must-haves. I need to have these features. If not, product is of no use to me. Those kind of features are called as must-have features. Most interestingly, it should be measurable. That is the most important part. Alright. After this CCR, from there you need to identify the project Y. Critical to quality, critical to delivery, critical to cost, all these are often called as CTQs. Okay, first thing is you have critical to success. Sorry, let me go back to the goal mean statement. Alright, we have discussed briefly about goal means. In this goal means, what is the first thing that we have done? We have looked into CTS, critical to success or satisfaction of customers. From there, we have broken that into critical to quality. From there, we have come up with critical to process. And from there, we have actually identified the project Y. There might be multiple Ys, multiple outputs that I want to influence or impact. That I wish to select one project, which is the most important. And how did we, okay, and this drill down tree anyways we have discussed. So project Y is one most important thing. And also, in order to identify this project Y, you can use something called as quality function deployment. And within this, there is something called as house of quality. House of quality is also used to translate your voice of customer into your project Y. And we have also discussed about the rules of splitting those things. And when we identify project Y, one more thing that we have discussed is that we need to look into primary metric and also secondary metric. Primary metric we obviously want to improve. Probably we want to improve the quality. If you want to improve the quality, what do you often do? You put additional rounds of testing. You do additional testing. If you do additional testing, will the cost increase or not? Yes, the cost will definitely increase. So it's not meeting our objectives. And increasing the quality of the deliverable, but at the cost of what? At the cost of additional expenses. Right? So that additional expenses should be secondary metric, and you need to always ensure that the costs are same after the improvement, or the costs are minimized while you do the improvement. You'll have to ensure that. Hence you have primary metric and secondary metric. If you say primary metric is improving quality, then secondary metric will be cost. You want to monitor even the cost. You don't want the cost to be increased. You want it to be decreased, or at least you want it to remain constant. Then came the project charter part. And we already know the components of this, but let us discuss once again. Business case is the most important component which creates urgency in the senior management. It provides the dollar values. Then we also have the opportunity statement. What is the pain area? Where is the pain area? How much is the pain area and all that? Oh, my bad. Once again. And then we have also discussed about the goal statement. Goal should always be SMART. What do you mean by SMART? Specific, measurable, achievable, relevant, and it should be time bound. This is all about goal statement. Then we have project scope. We always have to define what is in scope and what is out of scope. And then we come up with a project plan. Actually, project plan in project charter is always at a high level. Project plan, it contains high level milestones and it also contains high level timelines. Details will be at a high level in your project plan. Then we also need to mention the team member details. One thing that we need to understand is that team members should always be cross-functional. They should always be cross-functional. What do you mean by cross-functional? Cross-functional means team should be from different departments. Right, and then not just this, we have also discussed about how to calculate the financial benefits. How to calculate financial benefits. And what are the various ways that we have discussed? We have discussed about NPV, net present value. We have discussed about internal rate of return. And then we have also discussed about return on investment. Yeah, and also while you form the team, we know that it follows Tuckman model. Team formation always follows Tuckman model. What does Tuckman model say? First, the team is formed and it is called as forming stage. Then comes the storming phase, because people do not understand each other's attitudes. They come from different backgrounds, etc. Then after that fight and all that, they get into the normal stage once they get along or once they understand each other's attitudes. Then comes the performing stage. They perform at the peak because they gel well. They know each other now, like back of their hand, right? So they perform exceptionally well. And when they come to know that we are reaching the end of the project and we no longer would be working on same projects again together, that is when they feel bad. That is called as adjourning or mourning phase. Yeah, we have discussed about the Tuckman model also. Then we have discussed about how to manage team, how to address the resistance, right, and various other things. After this, we have actually gotten into our measure phase. Let me, all right. And one more thing, measure. So let me also highlight this in bold. Now, all right. So what did we discuss in the measure phase? We have covered a lot of ground even in the measure phase, but first of all, let us write down the points. We need to finalize the project Y, that is what you want to improve, kind of, right? You want to finalize. And you also want to set the performance standards for a Y. And the next step is you validate measurement system for this Y. Then you measure current performance and gap. So these are the three things that we were supposed to discuss. So we have discussed that measure phase has few inputs. And what are those inputs? Project charter, critical customer requirements, and high level map which we have prepared using SciPo. These three are the inputs of measure phase. Then what is the ultimate objective of your measure phase? I want to ensure, sorry, my bad. I want to ensure that the measurement system is reliable. Hence, I'll collect the data and establish a baseline for the project. I collect the data and then establish the baseline. These are a few things that I do. After inputs, objective comes your output. In output, the output is a valid measurement system. We will baseline this Y data. We baseline few other statistics and we come up with a detailed process map. And then in the analyze phase, we actually come up with a list of potential inputs. These are the various inputs, outputs, and tools and techniques. Within this measure phase, in this step 4, we have discussed about performance standard matrix. We first list down what is the item, whether it is continuous data or discrete data, right? Based on that, we decide what is the metric. We look into the opportunities, right? How many opportunities are there for defects? Kind of. We identify the data type. We identify what is the target, right? And not just this, we also come up with the specifications. Then what is the measurement source? How are we planning to measure? And how frequently are you planning to measure? So measurement frequency is also mentioned. Then after this comes your data collection part. So what do? First, in data collection, you look into data that is already available, already collected. Only this is not available, then you will need to collect the baseline data. And always, when you're collecting data, only if time permits, you need to go with the entire data. If time does not permit, you always have to go with the sample data. Right? If you have cost and time, then go with population data. If cost and time is a constraint, then go with the sample data. In this way you do the data collection. Alright, and then we looked into the measurement system analysis. Let me minimize this. So next we looked into measurement system analysis. And we know for a fact that measurement system has a measurement value. This measurement value contains the true value, the actual value plus measurement error. There might be error in the device that I am using. There might be mistakes in the way people are going to measure the data. Right? And then MSA, measurement system analysis, implies assessing the existing measurement system for the metric which was chosen for Y. Alright, and also we can say that this measured value is nothing but your observed variation. So let me write in different terms. So your mu, that is mean of the observed values, the total of that, is always equal to the actual mean mean actual of the part that you are measuring plus mean of the system. Yeah, so let me put it mean. So mean of the observed value is the actual value plus the mean of the system. Alright, then we have also discussed that, let me write it down in this way. Observed process variation is nothing but actual process variation and measurement system variation. Measurement system variation could be due to gauge or the instrument that you are using, or variation also could be due to operators. If there are 3 or 4 operators might be taking readings in a different way. Or sometimes the instrument that they are using to measure also might be wrong. Alright. Then variation due to gauge has 4 things. Accuracy or bias, precision or error, stability and linearity. What do you mean by accuracy? Accuracy is difference between average of observed values. First find out all the values, then take the average of that. How different is that average value from the standard value? This is your accuracy. Then comes precision. Precision is nothing but variation observed between repeated measurements or observations of the same unit and same unit. This can be because of your operator, or this can also be because of equipment. The next thing is stability. Stability means variation which occurs with time. Let me write down. Variation which occurs with time. It is observed that if the same operator measures the same unit with the same measuring equipment over a long period, then you come to know what is the variation. That is your stability. Last thing is your linearity. It is consistency of the measurement system across its entire range. How consistent is the measurement system? Yeah, then we have discussed about the differences between stability and linearity. Then we have also discussed in this measurement system itself, let me go back. Alright, in this measurement system itself, we have discussed about few other terminologies such as discrimination. What is discrimination? Discrimination is, suppose if the gauge Or let me put it in this way. The gauge or the instrument that you're using to measure should be able to measure smaller than 1/10 of the tolerance. If you're measuring weights or heights, the device should be able to measure till 1/10 of a kg, 1/10 of a kilogram, 1/10 of an inch, based on whatever you're planning to actually measure. Then we have also discussed about two more terminologies called calibration and traceability. Calibration, first thing. It is a process of adjusting the output on a measurement system. Excuse me for that. It is a process of adjusting the output on a measurement system so that it agrees with value of the standard that we have applied. For example, if we need to calibrate a thermometer periodically, we can verify that it shows accurate temperature or not. Calibration, we always check. We want to check for 2 or 3 kits and see how is that thermometer measuring the temperature. Then we have also discussed about traceability. What is traceability? Traceability is tracing, that's it, tracing back. If you have gone to Mumbai and come back to Ahmedabad, you want to trace back and see which route you have taken, how did you travel, right? You're just tracing back, right? It is nothing but an unbroken chain of comparisons to a national or international standard. We've also discussed about few things, right? NIST, I told PTB, but PTB has some, it's I think German-based company, and then we have Indian standards. So we have discussed about all these things. Then we have discussed that there has to be a company master gauge. Master gauge means master equipment. I measure all the equipments, measurement equipments with that master gauge. But one thing that we need to understand here is that no one should be allowed to touch the master gauge, and there should not be any rust or wear and tear. Then comes the precision. Within precision itself, you have two things: repeatability and reproducibility. A repeatability means if the same operator is taking multiple readings, is he taking the same readings or not? Right? So, measure same unit repeatedly with the same measuring equipment. That is called as the repeatability. Then we also have reproducibility. What is reproducibility? It is nothing but variation observed if two or more operators measure the same unit with the same measuring equipment. That is called as reproducibility. Then not just this, before going into our RNR, we have also discussed about the criteria for acceptance. And there is different criteria for continuous data and discrete data. Alright, let us discuss about continuous data. Whenever the data is continuous, you do gauge RNR. Please pay close attention to this, Anush, because here is where we were stuck. So for continuous data, we do gauge RNR. Right? In gauge RNR, we measure multiple things. One is accuracy, precision, and resolution. We measure these three things. And what are the indicators for accuracy? Percentage bias, or let me put it this way, or it is also percentage linearity. Percentage bias or percentage linearity. Here again we have three things. Either you can accept or cautiously accept or reject something. When you are accepting, this value should be less than 5%, only then you accept. If the value is between 5 to 10%, then you cautiously accept. If the value is greater than 10%, you actually reject it. This is with respect to accuracy. Let us discuss about what we have to do if it is precision. We look into percentage, gauge, R and R. In this also there are three things. You can either accept or cautiously accept or reject. If you want to accept, the value should always be less than 10%. For cautiously accepting, the value should be in between 10 to 30%. And if you want to reject, value should be greater than 30%. These numbers you have to 100% remember, because tomorrow we will be building on top of this. Categories. Number of distinct categories. Using this, you measure the resolution. Here also you have three things once again. When should I accept the measurement system? When should I cautiously accept the measurement system? And when should I reject it? You will accept it if the value is greater than 10. You cautiously accept it if the value is between 4 to 10. And you reject it if the value is less than 4. Yeah, this is all about gauge R and R if the data is continuous. Alright, if data is continuous, you'll do all these things. But what if data is discrete? If data is discrete, you do attribute agreement analysis. This is something that we have done in Greenbelt also. So we look into accuracy, we look into precision, right? Let me not get into the other stuff. Alright. Accuracy is percentage of the value, percentage value of appraisers versus standard. Here also you can either accept the measurement system or cautiously accept the measurement system, or you may want to reject the measurement system. When do you accept the measurement system? When the value is greater than 90%. When do you cautiously accept the measurement system? When the value is anywhere between 70 to 90%. And when do you reject the measurement system? If the value is less than 70%. Then comes the precision. You look into percentage within or between appraisers. Here also you might either want to accept it or cautiously accept it or reject it. Once again, you accept it if the value is greater than 90%. You cautiously accept it if the value is between 70 to 90%, and you reject it if the value is less than 70%. Yeah, these are the various things that we have discussed. And let me also add some more thing here. Discrimination is also called as resolution or granularity. Yeah, so if the data is continuous or discrete, this is how you do. But sometimes it might be very difficult for you to do gauge RNR. And that is when we do logical validation. That is, manually you just view it and then say, okay, we can proceed with this. Here also you have logical validation. If you cannot perform gauge RNR or something, or attribute agreement or attribute RNR, then you actually go for logical validation. Instead of attribute agreement analysis, let me put as attribute RNR. It will be easy for you to remember. Gauge RNR, attribute RNR. Continuous data, do gauge RNR. A discrete data, do attribute RNR. If gauge RNR is not possible, at least do a logical validation. If attribute RNR is not possible, at least do logical validation. Here you look into accuracy, precision and resolution. Here you look into accuracy, precision. And these are the metrics that you use: percentage bias, percentage RNR, number of distinct categories. And the acceptance criteria is provided here. When do you accept? When do you cautiously accept? When do you reject? For each and every metric, it's given. Similarly, for our attribute RNR also, we have given when we accept the system, when we cautiously accept the system, and when do we reject the system. All right, one last thing, and then we can probably break, but let me complete that part. All right. Within gauge RNR, you have two things. One is called as crossed designs, and one is called as nested designs. What do you mean by crossed design? It is used when each part can be subject to repeated measurements. So in the design, each part is inspected by each operator. Each part inspected by each operator. So if you have two operators, two parts, both of them will check both the parts. That is cross design. But the part will be the same in cross design. The same part, if there is part 1, the same part is checked by operator 1 and also by operator 2. If you have second part, part 2, the part is checked by operator 1 and also operator 2. But what happens in nested designs? In this design, each operator is given different parts, not the same part. Is given different parts to measure, but it will be from the same batch. Maybe from the same machine. Same machine manufactures, say, bricks for constructing house. So you are giving it to one operator. You are asking him to measure the strength of the brick. Strength of the brick, how will he do that? He will try to break the brick and check it. Once you break the brick, the different operator cannot measure that brick. So you are going to give him a different part. Hence, if you are going to give such different parts to each operator to measure, it is called as nested designs. Alright, so I'll do one thing, Anuj. I'm going to stop here.